Hey everyone, how's it going? Dan here, co-founder of PromptUp, and today we're going to talk about one of the more well-known, if not the most well-known prompt engineering methods called chain of thought prompting. And so we'll go over what it is, how it helps. We'll look at a bunch of examples because there's a lot of different ways to implement this method. Specifically, we'll look at how to automate this type of prompt engineering method, how it differs from few-shot prompting, where the limitations are for it, and then we'll wrap up. And so the basis of a lot of this information comes from a paper out of Google back in 2022, actually, called Chain of Thought Prompting Elicits Reasoning in LLM, so it will be linked below. And so to start off, what is chain of thought prompting? Essentially, it's a prompting method that enhances the reasoning capabilities of LLMs by encouraging them to break down their reasoning and actually show their reasoning in their output. So breaking down complex tasks into smaller pieces to solve. And there are a lot of ways to implement this. We'll start to take a look at some of those. Here is a very classic example pulled directly from the paper. So on the left, this is not chain of thought prompting. This is few-shot prompting. So it's sending one example here and then asking the question. And in the answer, it just says the answer. But on the other side, it runs through the reasoning. So it says Roger started with 5 balls, then this happened, so the answer is 11. And that's the difference. This blue highlighted text is that reasoning being shown. So why is it helpful? Again, breaking down complex problems into smaller, more manageable subtasks is always a helpful way to leverage LLMs. It can give you an insight into how the model's actually reasoning. Even in some cases when you push it to reason, those reasoning chains aren't always faithful or correct. And so this will give you an idea into how the model is coming to an answer. It's widely applicable. Basically anything that requires reasoning or thinking is a good use case for chain of thought. And it's relatively straightforward to implement. There are a lot of different ways to implement it, including some really easy ways. So we'll look at a bunch of examples, zero-shot chain of thought being maybe the most common. So when you see people say that, hey, let's think step by step, that is just one form of chain of thought prompting. And it's zero shot because you're just including it in the prompt. So you send the question, and then for the answer, you just prepend this let's think step by step, and that hopefully prompts the model to generate some reasoning steps here. And this text itself can take a lot of different shapes. There's a paper that tested a bunch of these different types of kind of prompt, just like small prompt pieces of text, and one of them that they found that worked really well for some of the Google models was take a deep breath and work through this step by step. So there's all these like little variants you can try, including these two on the left. And we have a very small template in PromptUp, which will be linked below. Next will be few-shot chain of thought. And in general, this is being pulled from the automatic chain of thought paper, which will be linked below as well. What they found there was their automated method beats the manual chain of thought, which is few-shot prompting, beats zero-shot chain of thought. And few-shot is, we looked at this before, it's when you just include examples in your prompt of how those reasoning steps should look. So everything highlighted here, this is all pulled from the original chain of thought paper. These are the reasoning steps. And so these are being sent to show the model, hey, here's a question, here's an answer, here's the reasoning steps. Here's the next question for you to then answer. And we have an example of this in PromptUp as well. Another method you'll see if you read any of these papers is sometimes they'll leverage chain of thought with self-consistency. So self-consistency prompting is just, when you generate multiple outcomes and then have a prompt to select the most consistent one. And you can leverage this with chain of thought, of course. You can leverage that with like basically any prompting method. Next up is not a direct example, but more of a variant. So step back prompting is a prompting method that we've kind of talked about before on our blog at least. And two-step process. First, as you can see here in the template, it tells it to abstract key concepts and principles before diving in and then solving the question. So that's another way for it to reason. You're pushing it to think broadly first. analogical prompting, which is actually similar to automatic chain of thought prompting. What this does is it tries to generate those chain of thought examples that we saw in those few shot chain of thought prompting examples a few seconds ago. So it will say, hey, here's the problem. First, identify some concepts, then recall 3 relevant and distinct problems. So these are the few shot examples we're going to be generating for each of one of them, describe it, and explain the solution. So this is a way to try to automate that process. And then it will follow that up by solving the problem. And so in this way, it's actually all in the output versus the examples being in the input. And there's implications to that. It's more expensive, but it might be might lead to better output since it's generating it on the fly, including the examples. Thread of thought is another kind of chain of thought cousin, I would say. And it's very similar to like the zero shot, where we're just kind of editing that reasoning text language here. And it really was initially designed to help keep a coherent line of thought across a large context. If you're doing RAG or something with really long dialogue or something like that, the reasoning text just, hey, walk me through this context in manageable parts, step by step, summarizing and analyzing as we go. Next up is another kind of cousin, I would say, is contrastive chain of thought prompting. And what this does, it kind of follows a good principle of few shot prompting, is that the examples you include should be diverse. And so in contrastive chain of thought, it shows a question and then it shows a correct explanation and a wrong explanation. And so this is a good example of showing the model what not to do, rather than having a bunch of stuff in your prompt that says, don't do X, don't do Y, don't do Z. And next up is faithful chain of thought prompting, which we touched on a little bit before, but sometimes the reasoning that is outputted, which is in blue here, and the final answer are not aligned. We could see the reasoning gets a final answer of 200, but the actual answer that the model generates is 0. And so while 0 might be the correct answer, it didn't get there the correct way, and so you would think that this prompt might break in other places. So you always want to make sure that the reasoning that's being outputted does align. Faithful chain of thought prompting tries to do this via 2 steps. So first, translate the query into like a more symbolic reasoning chain, so translating into something that's like executable, like Python, and then using a deterministic solver to derive the final answer. So it's similar to program of thought prompting in that way. And we again have a template for this in PromptHub, and here are a few more examples of that. Tabular, which I believe is our last one here, leverages Markdown essentially to have the reasoning steps outputted in a Markdown, usually a table, and this can help keep things more organized. And so the last one actually that we're kind of giving more of a presence to is automatic chain of thought prompting. And so basically this looks to overcome the problem of, hey, I want to use chain of thought prompting, I want to do few shot chain of thought, but I don't want to write out the examples myself. And as we saw before, analogical prompting kind of does the same thing, just in a different method. And so AutoCOT first, it takes it a little bit of a step further. It assumes you have a data set of examples, clusters them based on some similarity, and then it samples and picks from those clusters. And so the idea is to not pick more than 1 or 2 from a cluster, so then your examples are diverse. And here's what that looks like in a flow. And it just uses a zero shot prompt to then take those questions from the data sets and generate those reasoning chains. So it just says, it takes a question from each of these clusters, says, let's think step by step, and then eventually for the last one, lets the model fill in the answer. And as we saw before, based on their experiments, auto beats few shot beats zero shot. Some people ask us, what's the difference between chain of thought and few shot? Hopefully that's a little bit clearer now. So not all few shot prompts use chain of thought prompting, and not all implementations of chain of thought use few shot prompting. So let's think step by step. That's just a zero shot that doesn't do few shot. Then there is just few shot chain of thought, which we saw before when you include the examples. And then you could just have a few shot prompt that doesn't have any chain of thought, which is what we'd see below for this kind of classifier for feedback sentiment. In terms of limitations, the original paper found that the performance gains from chain of thought only occurred once the models were pretty big, like in the 100 billion parameter range, and that The smaller scale ones produced coherent sounding reasoning chains that were actually wrong and actually led to poorer performance than just standard prompting. And you can kind of see that over here in their chart. Like these really big spikes occur once the number of parameters hits, 100 essentially. Maybe this has changed. I'm not sure. Another one was the faithfulness and reliability. So then LLM can produce reasoning chains that look good, right? Like if you just kind of eyeball this, like, oh, this all looks fine. But it might actually diverge from its final answer. And then there's just, the work you have to do to actually implement it. And of course, there's methods like analogical prompting and auto COT to kind of help with that. And that is it for today. A little bit of a long one of a bunch of resources, free resources, and links to the papers below. Thanks.